بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. Some exercises about section 1.5. Find a formula for the inverse of this function. Well, to find the formula, we have y equals. So the next step should be solve this equation for x. Well, to solve this equation for x, I need to bring this down. And to bring it down, I will apply ln to both sides. And then ln cancels e, and I have 1 minus x equals ln y. Now, I will leave negative x here, take 1 to the other side. So I will have negative 1 plus ln y. Now I will multiply by a minus sign. So x would be 1 minus ln y. So I solved the equation for x. Next step, interchange x and y. And then write y f inverse of x. So this is the inverse function. If you want to check, replace x, for example, by 1 here. So 1 minus 1, 0, e to the power 0 is 1. So 1 goes to 1. If you replace here x by 1, ln 1, 0, 1 minus 0 is 1. So I checked with one number. It's not enough, but just to make sure that I accept this answer. So this is the correct answer. Another question. So the first step is to try to solve this equation for x. Well, this time I have ln. So either I use the definition or let me start by dividing by this 3, because having the 3 in front of ln as a coefficient of ln does not help, because the formula, I can use the formula now to change from logarithmic to exponential. The base is e, so I'll have x minus 3 equals e to the power y over 3. And then x would be 3 plus e to the power y over 3. If you like, you can raise both sides of this equation to the base e. Okay, you will get the same result. And now I interchange x and y, so y would be 3 plus e to the power x over 3. And finally, f inverse of x would be 3 plus e to the power x over 3. Let me check with a number. If I choose x, for example, 3 is not good because ln 0 is not defined. So let me choose x4. If I choose x4, 4 minus 3, 1, ln 1, 0. So 4 goes to 0. So if I choose x0 here, I should get 4. 0 over 3 is 0, e to the power 0, 1, 1 plus 3, 4. That's good. So I am pretty sure now that this is the correct answer. I need to solve this equation for x. So let me raise both sides to the power 1 over 5, or fifth root. Y to the power 1 over 5, I can write it fifth root of y equals 2 plus cube root of x. I'll take 2 to the other side, so cube root of x would be equal to fifth root of y minus 2. And now to have x here, I have to raise both sides to the power 3. So I will have x equals fifth root of y minus 2 all to the power 3. Now interchange x and y. And finally, f inverse of x would be fifth root of x minus 2 to the power 3. A quick check. Let me choose x1. Okay. So cube root of 1 is 1. 1 plus 2, 3. 3 to the power 5. 3 to the power 5 is a large number. 243. So if I put x1, 1 goes to 243. This means if I put x here, 243, I should get 1. So what is the fifth root of 243? Well, it's a 3. 3 minus 2 is 1. 1 to the power 3 is 1. So that's good. I am pretty sure that my answer is correct. Other type of questions, use the laws of logarithms to expand. Expand means write more than one len. So first I have square root. I can write it ln 3x over x minus 3 all to the power half. This is the square root. And I can take half outside. And now I can change the quotient into difference. So it would be len 3x minus len x minus 3. And that's it. So I will have half len 3x minus half len x minus 3. And this is how to expand. Okay. Expand this one. The main operation here is multiplication. So I will write it log to the base 2 of x cubed plus 1 plus log to the base 2 of cube root of x minus 3 to the power 2. I can write it x minus 3 to the power 2 over 3. And now the final answer. There is nothing to do in the first term, but in the second term I can take 2 over 3 outside to be the coefficient of the log. So that's the expansion. Express as a single logarithm. So I have 3 lens. I need to make them single logarithm. The first step is to take these numbers, the coefficients, up. So I will have x len x minus 2 to the power 3. Here, nothing to take up. Here, I will take 2 to be the power of x minus 3. All right. I have subtraction. Here minus and here plus. Well, if you know the formulas, I can write this at once. It would be len a fraction. This is minus here. So in fact, x squared minus 5x plus 6 should be in the denominator. In the numerator, I will have x minus 2 to the power 3. And this is a plus, so it will be changed to multiplication. So this would be the final answer. Or if you want, you can write len this over this and then multiply by this. You will get to the same result. First, I will write it log x to the power c base a minus log y to the power d base a, and then plus log z to the base a. Similarly, to change it to one logarithm, I will have a fraction because there is a negative sign here. So y to the power d would be in the denominator because of the negative sign, and up I will have x to the power c times z. So I wrote this as a single logarithm. Make a rough sketch by hand of the graph of this function. Use the basic function and transformations. What is the basic function here? Y equals log x to the base 10. What is the graph of this function? Well, the base is 10, so the graph is like this. And this is the vertical asymptote. Now to graph y equals log x plus 5 to the base 10, this means I will take this graph 5 units to the left. If you take it 5 units to the left, then the vertical asymptote will come 5 units, will move 5 units to the left. So instead of being x equals to 0, it would be x equals to negative 5. And this point 1, if you take it 5 units, it would go to negative 4. And the graph would be like this. So this is the graph of this function. If he asks about the domain is from negative 5 to infinity, and the range is from negative infinity to infinity. Another question, I start by y equals ln x. The base is e, and e is greater than 1. So that's the graph. Minus multiplying y by negative, this is a reflection about the x-axis. So all what you need to do is to reflect this about the x-axis. So this part will go up, this part will go down, and the graph would be like this. So this is the graph of negative ln x. This is a vertical asymptote, and the domain is from 0 to infinity, and the range is from negative infinity to infinity. What are the domain and range of this function? Well, I can find the domain immediately. The number inside the len should be positive. X minus 1 should be greater than 0. So x should be greater than 1. So the domain is from 1 to infinity. While the range is for the logarithmic function from negative infinity to infinity. So this is part A. Part B, what is the x-intercept? Well, to find the x-intercept, I put y0. So I need to solve this equation. I'll take 1 to the other side. And then using the definition or changing len to exponential, I will have x minus 1 equals e, the base is e, to the power 1. So actually x is 1 plus e. So that's the x-intercept. That's the x-intercept. Sketch the graph of the function. Let me start by the graph of ln x. The base is e, so this is the graph. Now, the horizontal translation, horizontal shift. So I need to sketch the graph of len x minus 1, 1 unit to the right. If you move this graph 1 unit to the right, the vertical asymptote would be here, and 1 would move to 2. And this would be the graph of the function. Now to graph f of x, he called it f of x. So just let me call it f of x. I need to move this or shift the graph of this function 1 unit down. When you shift the graph 1 unit down, the asymptote is not going to change, but this point 2, it would be here. So this would be the graph of the function. You will find that the domain is actually from 1 to infinity, and the range is from negative infinity to infinity. And you know that now that this x-intercept is 1 plus e, so it's about 3.7. This is 2, 3, and this is 3.7, the x-intercept. Solve each equation for x. Give both exact value and decimal approximation correct to 3 decimal places. Okay, to solve this equation for x, I will change it to exponential immediately. So 4x plus 2 is equal to e to the power 3. You need to memorize this, okay? Y equals ln x if and only if x equals e to the power y. This is the definition. We mentioned this in the lecture, so I always apply it. To solve for x, I will take 2 to the other side, and then I will divide by 4. So x would be negative 2 plus e cube over 4. This is the exact. He needs an approximation. So I'll just go to the calculator and write negative 2 plus e. E is there in the calculator. And you put the power 3 over 4. And the calculator will give you 4.521. After 1, there is a 3. So it remains 1. So these are 3 decimal places. Solve for x. Now x is in the power, so I apply ln to both sides. And ln cancels e, so I will have 2x minus 3 equals ln 12. Take 3 to the other side and divide by 2. So that's the exact answer. And you can use the calculator again to find an approximation. 3 plus ln 12 over 2. 2.742. And after 2, I have 4, so no change. Find the domain. The domain of Ln, what is inside Ln has to be greater than 0, positive, because the domain of Ln is from 0 to infinity. So this means that Ax is greater than 3. How can I solve this inequality? Both are positive, so I will apply n to both sides. Ln cancels e, so x would be greater than ln 3. This means that the domain is from ln 3 to infinity. That's the domain of this function. Find f inverse and its domain, f inverse of this function. First step, I write it y equals ln ex minus 3. And now I need to solve this equation for x. So I can say that using this formula, the one I wrote before, change it to exponential. I will have ex minus 3 equals e to the power y. I need to solve it for x, so I will keep ex here and take 3 to the other side. Now to bring x down, I apply ln to both sides. Ln cancels e, and I will have the value of x. Now I interchange x and y. And finally, I write it f inverse of x. So this is the inverse function. Let us check just quickly, okay, just to make sure. If I put x, for example, 0, it will not work. So this is difficult to check. I have to put x2, for example. If I put x2, then I will have ln e square minus 3. It's somehow not easy, so I'm not going to check. Unless I use the calculator, you know. I use the calculator to find ln e to the power 2 minus 3. So the calculator says about 1.48. So if x is 2, this will go to 1.48 approximately. So I should put here 1.48 and find ln 3 plus e to the power 1.48, and the answer should be close to 2. Well, the answer is 2, 2.00005. So this is the correct answer. Good. Still, we need to find the domain. Well, the domain of f inverse is the range of f. And it's a logarithmic function, so the range is from negative infinity to infinity. This is one way. The other way, I can think of f inverse. Domain of f inverse, this should be positive because it is inside the len. But it is always positive because this is a 3, this is a positive sign, and ex is always greater than 0 because the graph of ex is above the x-axis. So the domain of f inverse would be from negative infinity to infinity. Simplify this expression. Whenever you see sign inverse, you call it y. You use the definition. The definition says that x would be sine y. So sine y would be x, and sine y, we have sine inverse. So to sketch the graph, we from negative pi over 2 to pi over 2. So y could be here or here, and this depends on x. If x is positive, we will be in the first quadrant. If x is negative, we will be in the fourth quadrant. What do we know? Sine y is x. Sine y is opposite over hypotenuse. So opposite is x, hypotenuse is 1. I need to find the adjacent. Well, using Pythagorean theorem, the adjacent is square root of 1 square minus x square. So what do we need? We need tan sine inverse, which is tan y, because I called this y, and that's y. And tan y is opposite over adjacent. So it's x over square root of 1 minus x square. So that's the answer. I can write this like x over square root of 1 minus x square. Similar, I call y tan inverse x. I use the definition of the inverse function. X would be tan y. Well, tan is similar to sine from negative pi over 2 to pi over 2. So y would be here or here. Depends on x. Tan is the opposite over adjacent. So opposite would be x, adjacent would be 1, because this is x over 1. Now the hypotenuse using Pythagorean theorem is square root of x squared plus 1, because the hypotenuse is the largest side in the triangle. What do we need? We need sine. Why? Sine is opposite over hypotenuse. So the answer is x over square root of x squared plus 1. This was the last exercise. Enjoy studying math and have a nice time.